Okay, this is the second part of chapter 3, which is stoichiometry. In this subtopic, we will provide you an example of a question on stoichiometry. Basically, in this subtopic, we have to set up a stoichiometric table. Stoichiometric table basically look like this. This is species, and the name of the species, which is sodium hydroxide, glycerol stearate, sodium stearate, and glycerin, and then water as the inert. And then this is the symbol. This is initial concentration and the change in concentration, and then what is the remaining in concentration at the end of the experiment, and then lastly is the concentration from for each of the species. Okay, move on to the question. And the question is said that having set up stoichiometric table, we can now readily use it to calculate the concentration at the given conversion. Okay, if the initial mixture consists solely of sodium hydroxide at the concentration of 10 mole dm cube, concentration of sodium hydroxide is 10 mole, and glycerol stearate at the concentration of 2 mole dm cube. So, species A is 10 mole dm cube, and species B is 2 mole over dm cube. Okay, what is the concentration of glycerin when the conversion of sodium hydroxide is A is to 20% and B is 90%? Okay, in this subtopic, we use conversion of conversion equal to X. So for A, X equal to 20% and B, X equal to 90%. Okay, so the solution is only the reactant and the glycerol stearate are initially present. Therefore, at the initial phase, theta C and theta D equal to 0, because theta C and theta D is the product. This is the product. So they will have no concentration at the initial phase. Only A and B have the initial concentration. Okay, so from the question, we have to calculate the glycerin. Glycerin is species D. Okay, then for part A, X equal to 20%. So to calculate D is to use this equation. CD equal to Ca naught X over 3. Okay, then Ca naught is the concentration of our sodium hydroxide, which is 10, and X, which is 0.2 and 3. So we get CD equal to 0.67 mole per dm cube. Okay, so at the conversion of 20%, we get the concentration of glycerin equal to 0.67 mole per dm cube. Okay, and then at the 90% for part B, X equal to 90%, CD is equal to Ca naught, same equation, but in for this case, the X is changed to 0.9. So we get CD equal to 3 mole dm cube. Okay, we get the remaining of CD equal to 3 mole over dm cube. Okay, so how to calculate the limiting reactant? Okay, basically to calculate the limiting reactant, the answer will give a negative value. Okay, let's say if we try for B, which is sodium glycerol stearate. B is glycerol stearate. Okay, for example, at conversion of 90%, we get CB. The equation to get the CB is equal to Ca naught theta B X over 3. So equal to 10 2 over 10 minus 0.9 over 3. And then we get the value of negative 1 mole over dm cube. Negative 1 over mole dm cube. So from this calculation, we get the value of negative 1. This negative 1 shows that in this reaction, glycerol stearate is the limiting reactant because it gives the value of negative 1. So basically, this is how to detect the limiting reactant in a reaction. Thank you.